All right, let's go over this. And first thing that we want to figure out is if it's linear or not. If it's not linear, then it's exponential, of course, and then we can figure out an equation for that one. But if it's linear, then we need it in slope-intercept form. So I'm going to look at some ratios here. And if it's linear, so I'm just checking for linearity first, then the rates of change need to be the same. So from 48 to 24, this would go down 24, which again, you just take the second value, 24, and subtract the first one, 48. So that's why it's negative, which again just means it's going down, and that's okay that it's going down, but that's my numerator, down 24. And then the x's from 1 to 2 goes to the right one. So it's a negative 24 to 1 ratio, which simplified is negative 24, and that's okay. But let's look at the next set. So from 24 to 12, this goes down 12. So if you want to find that 12 minus 24, again, it's going down, so down 12. And then here, from 2 to 3, it's going to the right one. Okay, so it looks like we don't need this last ratio, because right now we can see these two, like this one, remember, is negative 24. Negative 12 to 1 ratio is just negative 12. These are not the same. And since they're not the same, this is not linear. So, since it's not linear, it has to be exponential. So we're expecting the equation then to be something like a times b, the base, to the power of x. So we just got to figure out what the a and the b are, the base. And since it's this table is not showing us where x equals 0, that would be our a value, that's our starting value, then we're going to have to figure that out ourselves. But that means that we're also going to need the base. So let's take this table, let's work with it again. Okay, so that was just to check, make sure it's not linear. Now I got to see what's being multiplied over and over and over. So I'm looking for my base on this one. And the first thing here, we've already seen the x goes to the right one there with the first two values, which means I can use the y values to find my base. Always take the second one, which is 24 in this case, put it on top, and then divide it by the first one, which in this case is 48, right? We're comparing those y values. Again, this is going to tell us what we are repeatedly multiplying by. The calculator is likely to show you 0.5, but I'm going to go with the fraction on this one of 1/2. It doesn't matter which one you choose, though. Okay, so my base, I'm going to show it as 1/2. And we can prove that. So if I said, well, take 48 and multiply it by 1/2, you'd get 24. And then you could take 24 and multiply it by 1/2 to get 12. If you take 12 and multiply it by 1/2, you get 6. And of course, you could continue this down the table if you'd like. But like we saw last time as well, it's important to notice that these x's are going up by 1 as well. So we can just multiply 1/2 as we go down the table. But to find the a value, I've got to go up the table. So where our operation here is multiply by 1/2, if I want to go up the table, then I'm going to have to divide by 1/2, which if I use the calculator, I'm going to have to use parentheses. So that means I would take that 48, and to go up the table, I would divide it by 1/2, which would give me 24. Dang it, not 24. 96, that's better. Okay, so why is that 96? It's because I went up the table, and that means I can go back one with my x, which would make that 0. So that's my ordered pair, 0, 96. But again, this is where x equals 0. And so my y value, the 96, that's my a. So in the equation, let's move some of the stuff around. So I already have the base, which I'm showing is 1/2. But I now have the starting value, the a, which is 96. So the equation, y equals 96, you can put the multiply there by base 1/2 to the power of x, and this one works. Like I said, if you want to use the decimal instead of the 1/2, that's fine too. Some students prefer it just because I think it's easier to put in the calculator. Now, speaking of the calculator, if you were to put this in the calculator with the y equals the equation function, and you were to put 96 times 1/2 to the power of x, you would get this table. Okay, again, we don't really need the graph, but you can graph it just to see what it looks like. But yeah, this one would be good for the table. Here's our objective. I can find and write expressions based on taxes, tips, and discounts, which is going to be a little bit different than what you remember in 7th grade stuff, or 8th grade, whenever the crap it was. But take 30 seconds to write this down, then we'll get started. But just kind of a quick review of percents. So we've seen this kind of stuff in 7th grade. Percent is really 2 words, per cent. Cent means 100, because it's kind of like a century. Per cent is per 100, which really means out of 100. That's why we get these types of fractions where you see percentages out of 100 like this. This also tells you how many hundredths there are. So if you saw 86%, this is the same as 86 hundredths, which as a decimal is 0.86. For those of you that remember, what they may have told you back in 7th grade is to just move the decimal 2 place values to the left. All right, now we got to be careful with this, because if you end up with something like, let's say 3.5%, a common error is where students say, well, this is 0.35 as a decimal, but that's not true right there. 3.5% as a decimal would be in hundreds, right? So you'd have to take the decimal 2 place values to the left, which would make this 0. And with the empty place value there, you put a 0 and then 3.5. So we're going to need these decimals because this lesson has a lot of decimals in addition to the next lesson. This lesson is really supposed to be a review of stuff you've already learned, just maybe in a different format, but then we're going to apply the things we learned today to the lesson next time. So once again, we see the percent proportion, which is probably something that you remember from 7th grade. Okay, the percent proportion is great, and it's pretty, and it's colorful, at least the way that I have it. But today, we're going to be using the percent equation. This is for 9th grade stuff. Now, the percent there is really like a percent of change, which we're going to have to keep in mind. Percent of change, which is kind of the name of our lesson. It's the objective for us today, which means that you take the whole, multiply it by the change, and then you get kind of like a part right there. For today's lesson, the problems that we're going to be seeing, the whole value is also like an original value or a starting value. And then the part will be the new value that they give us, okay? Now the percent of change is going to be shown usually as 1 plus or minus some kind of percent. And it's going to be addition. We're going to see addition if the context calls for adding. Okay, so this is going to be like an increase, or maybe you're getting more of something, it's going up, and then we'll use subtraction if it's going down. So there's a lot of interpretation in the wording here to determine if you're going to either add or subtract. We don't know which one it is until we read the problem. But hopefully through the wording, it'll be kind of clear which one it is. Now the one right there is because you're going to start with 100% of whatever it is. Most of these are related to money. You start with 100%, and then the plus or minus is the change, and then the percentage is always given in the problem. Again, whether it's going up or down. So these problems are going to look like this. Just be aware of it, and this is going to be the way that these set up in the next lesson as well. But since they're going to be repeatedly multiplied by the same value, then we start seeing exponents in the next lesson. But this is, again, just kind of an introduction to why this works. So our first problem, you are at a restaurant and the check comes to a total of $79. You want to leave a 17% tip. How much total money should you pay? And we'll round to the nearest tenth if it's necessary. But right here, we can see that you got a total of $79. That's the bill right now. It's kind of like our original value. You can say it's a starting value as well. Okay, so I'm going to take my starting value, my original, which is $79. And then it says you got a 17% tip on that one, okay? Now, a 17% tip is going to increase the cost or increase your bill. So that means we know we're going to be adding this 17%. Okay, so again, in my percentage, I have 1, which represents, that would be, if you just multiply this by 1, it'd be 100% of the bill. But since it's increasing, we're going to add, and then it was 17%, right? Well, we're going to add 17%, but we're going to have to show this as a decimal, so 0.17. So the 1 right here is representative of 100%. It's just 100% as a decimal. So if you wanted to, you could show it as 1.00, you know, if you wanted to. And then this will equal the new value, which we don't know yet, but that's what we're going to find. So I'm just going to type this into the calculator. All right, so I got 79, parentheses, 1 plus 0.17, close parentheses, enter, and it says, all right, you're going to pay $92.43. That's a pretty good tip right there. You're looking at over $13 tip, which is pretty good. Now, just so you understand, I don't know how often you guys go out or tip, but in the future, if you ever tip, make sure you leave more than $5, because if you do not leave more than $5, don't go back to that place, because you're likely to get more on whatever it is you're eating than you probably would want, and you'll never know. How do I know that? Because I worked at a pizza place where I didn't do it, but some other guys would. They'd give extra toppings, if you know what I'm saying. But people wouldn't know. So make sure you tip good. Otherwise, you may get extra toppings that you don't want. That's the answer we're looking for. If you want to buy an item in a store that costs $19 and is on sale for 30% off, how much would the item actually cost you after the discount, round to the nearest cent? So again, could you use a percent proportion to solve this? You could. And you could even use that 2 different ways. But again, we're going to go with what we're seeing today. So I'm going to stick with this formula. Okay, I've got it costs originally $19, so that $19 right there, that's an original cost. So I'm going to take that $19 and I'm going to multiply it by the percent of change. Okay, so again, this item, whatever it is, starts at $19. If I multiply it by 1, that would have been 100%, right? Now this one, it's 30% off, which means that it's going to decrease the value, or I guess the price. So we're looking for subtraction on this one. So I am going to subtract, and then the percentage that it gave us was 30%. Now again, it's minus 30%, but I need this as a decimal, which would be 0.30. That second 0 isn't completely necessary, but I like to see it just so I can see the actual 30%. And then this is going to equal the new value, which in this case is the sell price. All right, but I got to do this in my calculator because I can't do that in my head. If you can, that's great. I just can't do it. So when I do this in the calculator, it says, well, after taking off 30%, the price, it says 13.3 in my calculator. I'm going to put 13.30 because we are looking at money in this case. So there it is, $13.30 after a 30% discount. Now something you'll notice from this, if you were to do 1 minus 0.30, it's going to show 0.70, which is 70%. Okay, why is it showing 70%? Because you're going to pay, this means you're paying, the sell price is 70% of the original price. stock of company A gained $1.32 throughout the day and ended at a value of $34.32. By what percentage did the stock rise? Okay, so I see how much it gained, and what we're missing here is the percentage, right? Now, it says right here that it ended at a value of $34.32. So this is kind of my new value. It's the ending value, if you will. Or ending value. So in my equation, which I need this kind of where it starts at. So the original price of the stock for company A, then I multiply that by the percent of change, and then this would equal the new value. So what I'm missing on this one is the original price. I don't know the original price, and I also don't know the percent of change. I can figure out the original by taking the ending price, $34.32, and if I subtract how much it gained, which is showing $1.32, if I subtract this, then I have my original price, which if you do this, you'd get $33. Now again, this is my original price. You're going to see this is going to come back. But my original price then is $33. What I don't know is the percent of change on this one. I'm still going to keep 1 because that's 100%. And up here it said that it gained $1.32. Gain means addition, so it would be plus. And again, I don't know what this percentage is, so I'm going to use an X value there. And this would equal then the new value, which is $34.32. Now looking at this equation, some of you may divide both sides by 33 just because we've seen some literal equations before. In the past, though, I think you're more familiar with distribution. So I'm going to stick with that. So it'd be 33 times 1, which would be 33. 33 times x, which would be 33 x's. And then this would equal still 34.32. Now, since I want the percent of change here, I would solve for x at this point, so minus 33. Hopefully solving the equation isn't too bad. But then I've got 33x equals, you see this 1.32 comes back. But then I have to divide that to find my x by the coefficient of x, which is 33. And this will be x. This is my percent of change. This is my percentage. I guess it said rise. So I put 1.32 divided by 33. Enter. In my calculator, it's showing 0.04, which is a 4% change. So right here, that means that it would have been a 4% change. This also means if you replace the x here with 0.04, the percentage as a decimal, then 33 times 1 plus 0.04, if you were to put this in the calculator, you would get $34.32. So it gained this much. Again, we had our ending value right there. So we had to figure out this 33. So here's a common mistake. Students just say, well, 1.32 divided by 34.32, that gives us a percentage. It's close, but it's not exactly 4%, which is what we want. We need that exact value. So the stock of a company lost 3.5% today to $79.13. What is the opening price of the stock in the beginning of the day? Well, we don't know what that opening price is, but I do know that the opening price would have been the starting value. I'm going to call it the original value, or I missed the letter. Original. It's the original price of the stock. Okay, now after applying a 3.5% loss, then you have the new price on this one. And it's a 3.5% change, but again, loss right here means that we're going to be subtracting in the expression. So let's take the original price, which we don't know, right? We don't know what this is, so I'm gonna be using an X for that. So let's take the original, which we don't know, X, and then I'm gonna apply my percent of change. That's gonna be multiplied. So again, you take 100% of the price, of the stock. And since we're applying a loss, this is going to be subtracting the percentage that it was, which was 3.5%, which as a decimal is 0.035. Okay, so 0.035 subtracted from that. That would have been the new price, which was $79.13. So from here, you could distribute, but actually I see that I can just combine these, right? 1 minus 0.035 would be 0.965. And that's how much we're paying of the original. And this equals still 79.13. Now I'm going to reverse this. Hopefully that's okay. So I'm going to show it instead as 0.965, just so it looks a little bit more familiar, and then multiply that by x, because now I can solve for the original simply by dividing both sides by what I'm going to call a coefficient. So divide by 0.965 on both sides. And that will give us the x, which is the original price of the stock before it lost that 3.5%. So in my calculator, 79.13 divided by 0.965, enter, I get 82. Okay, so the original price of this stock would have been $82. That's all we want on this one. On these problems, you have to be careful which values they're giving you, right? Which ones you're solving for. The last problem we were solving for the percent. This one we were solving for the original. Ella goes to a restaurant and the subtotal on the bill was X dollars. A tax of 4% is applied to the bill. Ella decides to leave a tip of 19% on the entire bill, which means that we're including the tax. So we have to do this kind of in two parts. There's kind of a shortcut for this one, but we'll wait till the end to show that. Write an expression in terms of X that represents the total amount that Ella paid. So I'd have to start first with my tax. All right, so let's look at the expression. So this is what I got. Let's make this a little bit smaller. But I'd have to start with just the tax on this. Okay, so the tax, which is 4%, since it's a tax, we're going to add the tax. Okay, so in the percent of change, I'm expecting addition there. And we start with 1, but then it's 4%, which as a decimal is 0.04. So 0.04, the original value on this one, oh, that's what we don't have. We're looking for an expression. I don't know what the original value is, so I'm going to have to use an X on that. And I actually guess we're not even using an equation. So on this one, we don't really need this equals new stuff. Okay. If you were to add inside the parentheses there, you would get 1.04. And that's multiplied by X. I'm just going to switch those around and show it as 1.04X. Now, this is interpreted. This can be interpreted. This means that if you include with the 4% tax, you pay 104% of the, I guess, subtotal in this case. But then, in addition to the tax, they're saying, well, now we got to have a tip as well. So we're gonna tack on a tip to that too. So the same exact expression here. We're still looking at an original times the percent of change. And the percent of change, we know, again, you're paying 100%, but in addition to that, you're adding 19%, which is 0.19. So we're going to add 0.19. But the original, here we got to go back to, this is the original with tax. Okay, so that's the total with tax, which we see there just to the left is 1.04 times the X. Now evaluating this, 1 plus 0.19 is 0.19. And then we have 1.04 times x times 1.19. And right here, I can just multiply those two values together, the 1.04 and 1.19. I'm just going to put that in my calculator. 1.04 times 1.19, enter, and I get 1.2376, and then I would multiply that by x. So I'm putting the x there second on purpose. But yeah, this is the expression that they're looking for. And again, this can be interpreted, not that I think you really care to, but you can. You can say, with the tax and tip, you would be paying 123.76% of the subtotal. Now, like I said, you can take a shortcut on this, right? So we know you're gonna pay the original subtotal. In addition to that, you're going to pay the tax, which would be 104% of the subtotal. But then in addition to that, you're going to pay the tip of that much. So you could have just multiplied that by 1.19. If you were to put this in the calculator, you're going to get exactly the same value there. Noah bought stock in a company 2 years ago that was worth X dollars. So again, that right there would be an original value, which we don't know. During the first year that he owned the stock, it increased by 31%. So an increase tells us it would add that 31%. That's after year one. But then it says he's going to go a second year, and then the stock still increasing, so that's an addition right there, but it's going to increase by 15%, okay? Now what we want here is an expression in terms of x that represents the value of the stock after 2 years have passed. So for our equation like this one, actually, we don't want this to be an equation because it says up there it's an expression. So we just don't want to equal the new value. We can't really find it anyways because we don't know what we're starting with. But what we do see is percentage of change. So in this, I'm going to start with year one. Okay, right? It says the first year. So I'm going to apply the first year here. And the original amount we don't actually know. So I've got an X there. The percent of change, though, again, you're gonna start with 100% on this. And it said it was going to increase. So I'm expecting a plus right there, which it said was increase. And then the change, which was showing as 31%. Which as a decimal is 0.31. Now when I add these two values together for the percent change, then ends up being 1.31 times by x. I'm just going to switch these around just so it looks a little bit more familiar. It's 1.31 times the x right there. So that value right there is telling us that from the original price of the stock, the increase of 31% makes the new price 131% of the original. I may have made that a little more wordy than I should have, but hopefully that kind of helps, okay? Because 1.31 is 131% of the original price right there. Now that's only after 1 year. We see that this stock goes through a second year. So we're looking at a second year now. So we're going to take the original. And multiply it by the percent of change. Now the original, in this case, is for the first year. Now the first year, it's showing as 1.31 times the first price that it was before the first year. So for the second year, we're starting with the value that it ends after the first year. And then we apply the percent of change, which again, we're going to show 1 because that's 100%. And this one also is an increase, but it says right there for year 2, it's a 15% increase. So that would be 0.15. Now total, right here, in the parentheses, 1 plus 0.15 is 1.15. And all this stuff is being multiplied together. So it's 1.31 times x times 1.15. And I can actually combine those two. So I'll do that in my calculator. 1.31 times 1.15. Enter. I pushed the wrong button. So I got to try it again. 1.31 times 1.15. Enter. And I see 1.5065. And then I would multiply that by x. Now this is after 2 years, right? So this means that after 2 years, which is all we really wanted right there, after 2 years, the price is 150.65% of the starting price from the first year. There you go. And that right there, again, that's the expression that we're looking for on this one. Now, just as a quick aside on this one, the shortcut for this one is kind of like we would with repeated multiplication, right? So we took the original and multiplied it by this percent change, and then we multiplied it by this percent change. So what you can do is you can take the original on this, which is just x, like we've seen. And then you can take the percent change for year one. Which we know, just because we did it already, is 1.31, 131% of the original. And then you'd multiply that by the percent change for year two. Which was 1.15. And if you were to do this, again, I'm switching the order here, but you would get 1.5065 times the x. If you just multiply those two together, you get this coefficient. So you can kind of simplify this as long as you understand that it is repeated multiplication. Now, since the percentages were different, we do get these different percentages of change. What we'll see in the next lesson is that it's repeated of the same percent of change over many years, in which case we can just use exponents. But we'll save that for another time. There's the expression that we're looking for right there. There's our objective. I can find and write expressions based on taxes, tips, and discounts. But we did it a little different, right? We did it the 9th grade way, not the 7th grade way. And, well, hopefully you feel pretty good about that.